Hello, I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. You're very familiar with transformation of functions, right? You can do all the reflections on the x-axis or y-axis. You know how do we perform the vertical stretches and compressions, horizontal stretches and compressions, and also horizontal and vertical translations. But many times we have a very simple question in the test paper, and that is, what is the equation of a function when it is reflected on a line x equals to a or y equals to b? That is, what happens to the graph of a function when it is reflected on a horizontal line or a vertical line? That is what we are going to explore today in this particular video. Well, we'll begin with the very basics, looking into the key parameters for our parent function, this time an exponential function to the base 3 to the power of x, that is correct. And then we will see how do we transform this particular graph and get the results. From those results, we'll also derive a generalized solution, and this general solution, or rather equation, can be utilized for any graph or any function. So let's see, how do we do it? To begin with, we'll consider the graph of exponential function y equals to 3 to the power of x. So that becomes the base function. So the parent function we are working with is y equals to 3 to the power of x. Let us first draw this particular graph. To draw the graph, we look for the key parameters. So what are the key parameters to sketch this particular graph? We need to consider 5 things. The 5 things are: 1. End behavior, which is what happens when x value is very large but negative. So when x value is very large and negative, that is to say, when x approaches negative infinity, what happens to the y value? Well, as you can see, y approaches 0. And since it is in quadrant 2, it is also positive. So when x approaches negative infinity, y approaches 0. In quadrant 2, it is still positive. The other end behavior is what happens when x approaches positive infinity. That is this end, right? So when x approaches positive infinity, y value also increases infinitely large and y approaches positive infinity. So we have these two end results. Now the first one is also called the horizontal asymptote. Since y is approaching a value, 0 is a value, right? So we have a horizontal asymptote here, which is y equals to 0. Is that clear to you? Correct? So the domain of this function is all real numbers, as you know, right? We know domain is x belongs to real numbers, and the range is y is greater than 0, right? So range is y greater than 0. Let me write down here. And of course, they all belongs to all set of real numbers. Okay, y greater than 0. Okay. Now, the 3 points which we consider are the points where the x values are -1, 0, and 1. The 3 to the power of -1 will give us what? 1 over 3. So that gives us the first set. At -1, we have a value, 1 over 3, and that is the point A on this particular graph. So that gives us the value for point A on the graph. The next value is what happens when x value is 0. Anything to the power of 0 is 1, and so we get the second value, which is the point B on the graph, which is also the y-intercept, which is 0, 1. Point C is when x is equal to 1. 3 to the power of 1 will be 3. So we get this point 1, 3 on the coordinate plane, as shown here as point C. So these 3 points are the key points along with horizontal asymptote and what happens when x is infinitely large. Those 5 parameters define the graph of exponential function 3 to the power of x, as you can see here. Clear? So that is how you will actually sketch the graph of 3 to the power of x if it is not given to you. Now, based on this, we have 3 questions for you to answer. Here is question number 1. Question number 1 is, find the equation of the graph of y equals to 3 to the power of x that results from the reflection about the line y equals to 2. So we're looking for a reflection about a line y equals to 2. Can you tell me what is this line y equals to 2? Is it a vertical line or a horizontal line? Think about it. Well, here is question number 2, which says, find the equation of the graph of y equals to 3 to the power of x that results from the reflection about the line x equals to 3. So this x equals to 3, is it a vertical or a horizontal line? Can you tell me that? Okay. Once we understand reflection about horizontal and vertical lines, this is for a particular value, we could generalize the result. And related to that, we have question number 3 here, which says, generalize the result of reflection about x equals to a or y equals to b. Perfect. So now let us see how do we sketch this graph and how do we find the equation of. Now let us see how do we find the equation of the transformed function which is reflected on horizontal or vertical line. So the very first one is related to y equals to 2 becomes the line. So the question here is reflection on the horizontal line y equals to 2. So the remainder of the question is, find the equation of the graph of y equals to 3 to the power of x that results from the reflection about the line y equals to 2. So we have this table once again for you. Already we have discussed how do we get these values. Now we'll figure out what will be the values after the transformation, that is, after reflecting the graph on the line y equals to 2. So let me now sketch the line y equals to 2. Well, y equals to 2 is a horizontal line where all the values are y equals to 2. So this horizontal line is y equals to 2 for you. We have to reflect the graph on this particular line, correct? Now reflection, you understand, the image will be same distance away, correct? Image will be same distance away. So what is very clear from here is that we had a horizontal asymptote which was at 0, right? Now when you reflect this, these 2 units, it will go 2 units up, correct? So clearly the horizontal asymptote now will be at y equals to 4. Do you get it? So we have the new horizontal asymptote. Let me say horizontal asymptote prime will be now at 2 plus 2, which is 4. So at y equals to 4. Is that clear to you? So that is the horizontal asymptote which we'll get now for the graph of the function which is reflected on y equals to 2. So the whole idea here is that image is as far behind as the object, right? So image is as far behind. Okay, or you can say image and object are same distance away. We can call this as a mirror. So that is the concept which we are going to follow. So the point which is A for us, where will that be? Let's try to figure this out. Well, this point A will now be reflected on the line. So it was 1 over 3 above the x-axis, now it will be 1 over 3 below the y equals to 4 line. You get the idea. So as far as the point A is concerned, let me rewrite this. The x value is going to be same, right? Since it is reflection vertical, right? So we're looking for vertical reflection. On y equals to 2, right? So that is what we are trying to do. So when you reflect that, then the x values will remain same, right? Y changes, correct? So y changes. What is going to be the change? Anyway, let's write down the x values, which are going to remain same, right? So these three will remain same. Now let's figure out what happens to the y value. Well, clearly, what we saw here is that the y value will be 4 minus 1 over 3. Is that clear to you, right? And in this case, it will be 4 minus 1, and then it will be 4 minus 3. Is that clear to you? So those are going to be the new y values. You can calculate these values and plot them. So 4 minus 1 over 3 will be 3, 2 over 3, correct? 3, 2 over 3, right? So that is your point A prime. So we can write that the A prime point will be minus 1 and 3, 2 over 3, right? As far as B prime point is concerned, it is at 1, it will be 4 minus 1, which will be at 3, correct? So that is how we are going to get the second point, which will be at 0 and 4 minus 1, which is 3. And C prime, which is reflected on the axis, which is y equals to 2, was at 3, will now be 4 minus 3, so that means it will come at 1, right? So the point at 1 will now be at 1. So these are the three image points. Is that clear to you? Now we have these three image points. So these three are the image points, and we know that the horizontal asymptote is y equals to 4. So we can now connect these points and get this part of the graph. On the other hand, we'll see also the asymptotes. Well, when x approaches negative infinity, y value now approaches what? It approaches a value which is 4 minus 0. Do you see that? It approaches the value which is 4 minus 0. So that is the value for horizontal asymptote. So now the horizontal asymptote is y equals to 4. As far as x approaches positive infinity is concerned, the y value becomes negative, right? 4 minus negative, correct? So when x approaches positive infinity, y approaches negative infinity, right? So it gets reflected on the particular line. So this value, which is going up, will now go downwards. You get the idea, right? So connecting these points, we have a graph which will kind of look like this. Does make sense to you? So that is how we will get the graph of the function. Let us call this graph of the function as g of x, right? So g of x is translation of 3 to the power of x. Rather, reflection. G of x is the reflection of 3 to the power of x on y equals to 2. Is that clear to you? So that is how we get the graph. Now we need to understand what could be the equation of this particular graph, right? So now the question for you is find the equation. Is that clear to you? We have already sketched the graph. Now take your time to find the equation of this particular graph. How can you do it? Well, you could treat this graph as what? You could treat this as a reflection and translation combination, right? So we could think about reflecting a graph kind of like this, right? Reflecting a graph kind of like this, and then pushing it up. That gives you the equation. So that is a hint, right? So I know with this hint, you must have got the equation. Perfect. So you have to reflect on the x-axis. So you get minus 3 to the power of x, and then move it up by 4 units. Perfect. So that is plus 4. Right. So what do we get? So we get the function g of x as equal to minus 3 to the power of x. That is going to reflect it, and then plus 4, which is going to move it up by 4 units. And that is how you get the equation of the graph of y equals to 3 to the power of x when it is reflected on the line y equals to 2. Is this part absolutely clear? Perfect. Let's look into this solution with the help of our graph, right? So as we did earlier, what we have here is we have the graph of y equals to 3 to the power of x. So that is the graph of 3 to the power of x. And then this is the line which is y equals to 2. When you reflect the graph, the point A is shown here as A prime, B is shown there as B prime, C moves downward. And this part, the end behavior, as you can see, when x approaches infinitely large, y approaches negative value but infinitely large. As far as the x approaches negative infinity, y actually approaches the value 0 but from under, right? So this is the graph, and that becomes the horizontal asymptote, which will be y equals to 4, right? So that is the horizontal asymptote for the reflected graph, correct? And with these key points, we have sketched the graph as such. Now, as far as the equation is concerned, we did find the equation, which was y is equals to minus 3 to the power of x plus 4. And before that, we wrote that the points x and y will now be translated to the position, I should say reflected, x to minus y, reflection on the x-axis, and then translated up 4 units, plus 4. That is going to give us the effect of reflection on y equals to 2. You get the idea. So you also understand that this reflection is also equivalent to two other transformations, right? Is also equal to this reflection on y equals to 2 is equal to reflection on y equals to 0 plus translation 4 units up. Is that clear to you? So you can have a question sometimes where we could find the equivalent transformations. You get the idea. So that is how they are equivalent. Now, let us try to generalize the result. How will you generalize this result? That is to say, what happens when you reflect on y equals to b? That is the whole question, right? So if you have y equals to b, in that case, the translation will be 2b. You get the idea, right? So the equation will be y equals to minus 3 to the power of x plus 2b, right? So that becomes the general equation after reflecting any graph about a horizontal line, which is y equals to 2. So I hope now this concept of what is the equation of the line when the reflection is on the horizontal line y equals to 2, I hope is absolutely clear. So in general, it will be y equals to minus, since it is reflected on a horizontal line, plus twice the value of y. Do you see that? So in this case, it will be 4. Perfect. So we have got one result. Now, let us see what is going to be the equation when we reflect the graph on x-axis. So here is the question for you. Just a reminder, question number 2. Find the equation of the graph y equals to 3 to the power of x that results from the reflection about the line x equals to 3, right? So x equals to 3 is our line on which we are going to reflect it. The function given to us is y equals to 3 to the power of x. We want to reflect on x equals to 3, right? So when you reflect on x equals to 3, how will the graph look like? Well, let's draw the line x equals to 3, which is a vertical line, correct? So let me draw this line here. That is the line x equals to 3, right? So we'll say this is the line which is x equals to 3. Now when you reflect, the points will be same distance away. Y value will remain same. And therefore, if I have a point xy, in that case, the x value will change, but y will remain same, right? So y value remains same in this particular case. Now, so horizontally it is being reflected. So that is the result. So we have horizontal reflection. Okay, so y values remain same. But the second thing is, it will be same distance away. So if I look at the point, which is the y-intercept, which is b for us, b is how much away from the x equals to 3? 3 units, right? So it will go 3 further away. So that will be at 6, correct? So point b, let me write b prime, will now be at 6. So at least we have one point, which is point b. So now, instead of this being at 0, it will be at 6, and the value will be 1. So point B, which was the y-intercept, now happens to be moving to the right side. After reflection, it will be 6 units away, right? So that is where it is going to be, correct? Because it is twice distance away. Now, A is further away by 1 unit, so it will go away by 1 more unit. So that is to say, this will be at 7, right? The value of this particular, sorry, this is at -1. So -1 will be at 7. And the value of y will remain same. The other value is a bit closer, 5 units away. So that is going to be closer, right? So that will be at 5. So at 5, the value will be at 3. So we get our values for the translated, rather reflected function, right? So there are two operations, equivalent operations going on. So we get the points as you can see from here. Now, let's look into the horizontal asymptote. So as far as horizontal asymptote is concerned, when x approaches negative infinity, y approaches 0 for 3 to the power of x. What will happen after reflection? Well, minus becomes plus infinity, right? So it will be when x approaches positive infinity, in that case, y approaches 0 plus, y value being exactly similar. So that part will be kind of going like this. Is that clear to you? Right? So we get our horizontal asymptote. Now what happens when x approaches positive infinity? Well, when x approaches positive infinity, after reflection, x will approach negative infinity and the y value will also approach positive infinity. I mean, remain kind of same, right? So we do have points here which could now be shown in this particular diagram. So what we have here is that all these points will now get reflected, and we will see that how they are going to, well, we have a very limited part shown here. In that case, it is going to be kind of like this, right? Is that clear to you, right? So every point will be kind of like that, reflected as shown here. Let me show you the exact graph in the next page. So what really happens is that each point goes same distance away, right? So if this distance and the distance there is maintained, they have to be same distances, right? So that is the property of reflection. So the point here will be same distance away, right? Do you see that? So these 2 points will be same distance away. X equals to 3 is the midline, right? Of course, at the end, I mean, as you go further, their graphs are going to cross one another. Perfect. Now, we understand how do we get the graph of 3 to the power of x when it is reflected on the line which is x equals to 3, right? So it is reflected on the line x equals to 3. Now, we need to figure out what is going to be the equation of the line, right? So we have to find the equation of the graph of y equals to 3 to the power of x when it is reflected about the line x equals to 3. Now clearly, as far as the points are concerned, we saw that x and y, the original points, will now get translated to minus x, since there is a reflection, plus 6, since it is twice away, 2 times 3, add 6, it goes to 6 further, right? And y value remains same. So that becomes the coordinate of the new point, correct? So we got those points in the previous calculations. Now, what is going to be the equation? Well, since it is a horizontal reflection, let me write down here, it is a horizontal reflection, right? Plus, it is a translation of 6 units, right? As we saw, right? 3 times 2, right? How do we get 6 units? It is 3 times 2. We get 6. Therefore, the equation will be 3 to the power of minus x, which is horizontal reflection. Let me write in brackets. Moving 6 units to the right will give us minus 6, correct? So that becomes the transformed function's equation. When you reflect the graph of exponential function 3 to the power of x on the line, which is vertical line, x equals to 3. Got it, right? So that is how you're going to get your equation. Perfect. Now, what could be the general equation? Now let's look into the general equation of the line when x is equal to a. That means when you reflect it on a vertical line x equals to a, it will move twice the distance to the right, and therefore the equation will be x minus 2a, and outside minus for the reflection. So we have that equation given for you. So equation is y equals to 3 to the power of minus reflection on a vertical line and x minus twice the value of a if the graph is reflected on x equals to a. Is this clear to you? So that brings us to the end of this particular video. So I hope you have understood the concept as to how do we sketch the graph of any function which is reflected about a vertical or a horizontal line, correct? We also understood how do we write its equation. So now, here is an additional question for you. Question for you is, you can take the function y equals to e to the power of x and then reflect on x equals to, let us say, 3, and I want you to do both the operations, x equals to 3 and y equals to 2. When you do that, what is the equation of the resulting graph, right? So find equation. Is that clear to you? Let this be your practice test question. I hope you find the video interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that will be great. Thank you and all the best.